Hello everyone. So today we'll be solving the problem number 743 network delay time, right? So let's see what the question states here. We are given a directed graph of n nodes. See here, suppose let's consider the example one here. So we are given a directed graph here, right? So pointing to some node, right? The arrow pointing to some node. Yeah, we are given a directed graph of n nodes and edges times of I equals u v w. U in the sense the first node, v u nothing but the source node. We call it as source node. V nothing but the destination node. W is nothing but the weight. Suppose here if we consider this one, so suppose we consider 2 1. Here 2 is nothing but u actually. Sorry, one second. Just give me a second here. 1 second. Yeah, this 2 is nothing but u. This 1 is nothing but the v destination node pointing to this one. And this one, this value 1 is nothing but the w actually. Yep. Same goes with every other this thing actually. So this one, if you consider u, 2 again, so this one will be v, this one will be w. So again, so this becomes u from this edge actually, 3 to 4 actually, right? Same thing. And w becomes this one. Yeah. So here we have been given UVW representing signal travel times, right? So the signal starts from the node K. The signal starts from the node K. K we have been given here. K we have been given 2. So this is K we have been given 2. This is the signal node, right? So the signal starts from the node K spreading through all the connections. So this is the K actually accordingly with the question, right? We must find how long it takes for all the nodes to receive the signal. What we have to find actually here, we have to find how much long it takes for all the nodes to receive the signal, or we have to return -1 if any node can't be reached, right? Essentially, we have to find the longest, shortest path from K to all other nodes, right? Shortest path, to find the shortest path, we have so many algorithms, right? So for this, as we are dealing with the positive integers only, see here, as we are dealing with only positive integers, let's do one thing. Let's go with the Dijkstra's actually. Yeah. If you don't know the Dijkstra's algorithm, you can just go through the graph based algorithms and you can, there you'll find the Dijkstra algorithm. You can watch the video and come. So that you understand this one quickly, whatever we are implementing, right? First, before hopping into the approach, I'll just say we'll be going with the Dijkstra actually. We'll be going with the Dijkstra, right? So let's discuss this one step by step by considering the example one. Actually, you can do the same thing or you can implement the same thing, whatever we discussed by considering the example two, right? Now, the first step, as I've said, we'll be going with a Dijkstra's algorithm, and Dijkstra's algorithm uses priority queue. Yeah. First of all, we are making use of the Dijkstra's algorithm, and we know that Dijkstra's algorithm uses priority queue. Right. So first example, we are going with this example itself, 211, 231, and 341. N we have been given for N here in the sense nodes, number of nodes actually, 1, 2, 3, 4. We have 4 nodes, right? And we have been given 4. And K in the question they have mentioned what is K, right? So this is fine, right? Yep. So this 2, 1, first this one UV actually, edges actually, UV again, UV. The last one is nothing but the weight. This is W. Everywhere. So this is fine. So the first step here would be, suppose we have to build the graph, right? First step is building the graph actually. So I'll just give you build graph. So the graph is already shown actually. So this is the reference actually. Yep. So this is fine. To this one. 1 second. Yep. We will start from the node 2 actually, as I've said, right? So we'll start from the node 2. Distance of 2 is 0. Initially, distance of 2 is 0, right? So we will visit from 2, we will visit 1 as well as this part. We will visit 3, right? So directed graph they have strictly mentioned. We will visit 1 and we can visit 1 and we can visit 3, right? So here, distance of 1, initially only distance of 2 we will consider. Distance of 2, this one will be initially we'll be setting this one to 0, right? So distance of 1 is nothing but from 2 to 1 actually. Distance is 1 and distance of 2 is nothing but this one. What do we call? Sorry, not distance of 2, distance of 3 actually. Distance of 3 is nothing but 1. This edge actually, this edge, this part, right? So this one we have the value 1 here. For this one also we have the value 1. And from 3 we can reach 4 here. See, from 3 we can reach 4, and distance of 4 would be quite obviously 2, because we are considering from 2, not from 3 to 4, right? So we are considering from 2 to 3 and then 3 to 4, right? So we are considering from 2 to 3 and then 3 to 4. So this one will be 1 plus 1 actually, right? 1 plus 1. So we'll go with distance of 4 equals 2 here. Distance of 4 equals 2, right? All nodes are reached here. Maximum distance is 2. Maximum distance is this one. Maximum distance 1 plus 1 that we did, right? So this is the maximum distance, quite obviously, right? So maximum distance is 2. So the output, the maximum distance that we got here is 2, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities. But so what will be the time complexity here? The time complexity would lead to big of E log V. The time complexity would lead to big of E log V. Why it is E log V here? Each edge is relaxed once with heap operations. Dijkstra uses heap itself, right? Heap in the sense it uses priority queue actually. Yeah. So each edge relaxed once with a heap operation. So overall time complexity, we can just write it here because E log V. Yep. So what will be the space complexity then? Space complexity would lead to because V plus E, right? So why it is V plus E here? So we will be making use of the adjacency list, a distance array, and the priority queue, right? So overall, it leads to big of V plus E, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of E log V and big of V plus E respectively, right? So now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Just give me a second here. Yeah. First thing, what shall we do? Let's create the adjacency list. Yeah. So this one will be graph of u equals list of v comma w, right? So this is fine. List of int. This is fine. Graph g. So let's make use of one more array here. We have to variable g graph. So I'll just go with new list of let me go with a size n plus one here, right? So this is fine. The next step would be, let's go with a simple for loop here. So this one will be for I equals 1, I less than or equal to n. And finally, let me increment the I, right? So this one will be g of I equals new array list, new array list. This is fine. Yeah. The next one will be another for loop. So this one will be int e of times. So this is fine. I'll just go with g of this one, e of 0 actually, e of 0 dot add of this one. What do we call? New int of, this is fine. So within this one, let me go with e of 1 as well as within the flat bracket. I mean e of 1 as well as e of 2 actually. Of 1 h2. So this is fine, I believe. So let me give semicolon and let's move on with the further things actually. Yeah, first we have to go with the distance array, and distance array that's initialized to infinity. Yep. So let's do one thing. Just initialize this one and then let's fill that one with the infinity. Yep. Just go with here new int of size n plus 1. This is fine. The next thing is I'll just go with arrays dot fill here. So this one will be d comma integer dot max value, right? So integer dot max value, and d of k, let me go with a 0. Yep, so this is fine. The next step would be let's go with a minimum heap for selecting the smallest distance node. Yeah, I'll just go with priority queue. Priority queue. Let me go with the int here. Let me go with the int. This is fine. PQ or the priority queue equals new. Let me copy this one and paste this one priority queue. Yep. So I'll just go with a comma b here. A comma b lambda. So this one a of 1 minus b of 1 hyphen b of 1. Yep. So this is fine. Yeah, we are just going with a minimum heap for selecting the smallest distance node here. So I'll just go with pq dot offer new int of let's go with a k and 0. Let's go with a k and 0. Let me give semicolon and let's move on with the further steps actually. Now let's go with a standard distrust algorithm. Yeah, let's move on with a standardized while loop actually. Right, so this is fine. Pq dot, let me go with the is empty here. So this is fine. So within the while loop, first thing I'll just go with a current. So let me go with 4 here. Yep. PQ is the variable name that we have considered. This is fine, man. Next, let's go with U as well as the T. U, let me assign this one to the current of 0. And also T, let me assign this one to the current of 1. Yep. The next step, we have to skip if it is outdated, right? So I can just write the simple if condition here. If T is greater than D of U, for skipping, I'll just make use of the continue keyword, right? So let me give continue here. The next step, let's go with a simple for loop. We have to relax, right? This one, we have to relax the edge node actually, step by step. So mm, basically, let me consider individual neighbor, right? Of all the, for the particular node that we have considered, all the neighbors, right? So I'll just go with here int neighbor of 0. Oh, sorry, not the neighbor of 0 actually. Here we have to consider individual neighbor. Sorry, writing for loop. Yep. So this one will be g of u. Right. So within the for loop, let me do one thing. Let me assign v to neighbor of 0. This is fine. W equals neighbor of 1. Yep, neighbor of 1. Now let's go with a simple if condition here. If d of v, if d of v is greater than d of u, is greater than d of u plus w, then d of u, d of u, uh, sorry, then we have to go with the d of v, not the u actually. D of u, let me assign this one to the d of u plus w nothing but the weight here, right? So this is fine. Let me go with pq dot offer. This is fine. New int of fine, yeah. New int of this one v comma d of v, yeah. So this is fine, man. So yeah, let me come out of this one entirely. Yep. So the final step would be we have to find the maximum distance, right? So in the question they have asked us to find the maximum distance itself. Yep. So this one I'll just assign resulting variable. I'll consider answer here ans. Initially, let me set this one to or initialize this one to 0. So let's move on with the for loop here. So this is going to be the last for loop. So this one will be I equals 1, I less than or equal to n. So let me increment the I. So within the for loop, so let me write the simple if condition here. D of I, if it is equivalent to integer dot max value, somewhere I have written this one. Let me copy this one entirely. Let me paste it over here. Max value. So I'll just return -1. Yeah. So if it is unreachable, if the node is unreachable actually, then we have to return -1 in that case. So that's what I have done. So finally, let's set the answer to. So we have to go with the maximum distance actually. I'll just go with the math.max of answer. All I have to pass is iterated value of the d, nothing but d of I here. Yep. So we are done with this. Finally, let's return the resulting variable answer, right? So where answer will be stored actually, right? So yep, let me format the code once and let me hit the run button. I hope this works actually. This is pure Dijkstra's algorithm, man. Pure Dijkstra's algorithm implementation. Yeah. Again, if you don't know the Dijkstra's algorithm, you can just go through the graph based playlist and you will find the Dijkstra algorithm. You can just watch the video and come, right? So this is fine. I can just watch the video. You'll understand this one. The implementation becomes very easy if you know the algorithm. It will be very, very easy. I'm not gonna lie. Yeah, if you know the algorithm. So this is fine. The sample test cases are getting passed here. So let me hit the submit button. I hope this works for all the test cases. Let's see. So you can see here, all the test cases are getting passed. So whatever that this one code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.